This is section B. It is 55 marks. We are told to answer all the questions in these sections in the spaces provided. So 15A, on the axis provided, sketch a graph of capacity against area of overlap of the plates of a parallel plate capacitor. So let's start with the capacitor. A capacitor is an electronic device for storing charge. Then we say one of the factors affecting capacitance is area. And that is, by increasing the area of the plate, we increase the charge on the plate. That is, capacitance increase, and therefore when we are given this capacitance and area, to sketch, we are required to sketch the graph of capacitance. So you will make a straight line. You can use a ruler. So that is the sketch. So as the area increases, capacitance increases. So that's how you answer that question. Part B of question 15, Roman number 1, draw a circuit diagram that may be used to investigate the discharging process of a capacitor. Discharging a capacitor means capacitor giving, since we have said that a capacitor is used to store charges, discharging means capacitor giving up the stored charges. We use a resistor to discharge by short circuiting the capacitor, as this diagram shows. So let me draw the diagram showing that. So the diagram, you could say this is a milliammeter denoted MA. You connect this. So here is where you connect your capacitor, and you proceed like here is where you connect your source of power. So this is the battery or the DC source. Then we can put a switch here, which can be denoted that way. Then we will connect our resistor here. This is our resistor. So this is our R. So this will come there, and that will be the connection. So this is a capacitor. So this will be able, once you crosses the switch, you will be able to discharge the capacitor. Again, we can say, or we can also connect it like this. So we have that. We put our source of power here. Then we bring it down here. We make connect other lines here. Here is what we connect milliammeter, and then we have our capacitor here. Then we connect that, and then here we will be able to have our resistor. So this is our resistor, and we make we can make okay, here we can make a switch here. So like that. So these two circuits are correct. They will be able to discharge the capacitor. So that's how you are supposed to answer that. Roman number 2, we are told, on the axis provided, sketch the graph of potential difference between the plates against time for the discharging process. So we say that, so we have the graph potential difference on the y-axis and time. To explain this, we say, as charge flows from one plate to the other through the resistor, as we have seen the previous part, the charge is neutralized, and so the current falls. The rate of decrease of potential difference also falls. Eventually, the charge on the plate is zero. Also, current and potential difference are zero. The capacitor is, we say that the capacitor is fully discharged. So this means that as you are discharging, the potential difference decreases with time. So we can now represent that process like this. So we say as time goes, potential difference when you are discharging decreases. So that's how you answer that question. So number 15C, we are told figure 7 shows 3 capacitors connected to a battery, 6 volts battery. So we have, this is our capacitor, and 2 microfarads capacitor, 3 microfarads capacitor. So 2 microfarads and 3 microfarads capacitors are connected in parallel. So these are parallel. That is 2 microfarads and 3 microfarads. Then so these ones we are supposed to add them to get the total or resultant capacitance. Then 4 and the sum of these are parallel. So what we do, because these two are parallel, we say the total capacitance here is 2 plus 3, and that will be 5 microfarads. Then because the two are parallel in series with the 4 microfarads, we are going to say 1 over C is equals to 1 over 5, the combination of the two, plus 1 over 4, the capacitor of 1 microfarad, 4 microfarads. So this means that 1 over C, mathematically you can get the LCM is 20. So this will be 4 plus 5 is equals to 9 over 20. So this means that 1 over C is equals to 9 over 20. So cross multiply, you find that this implies that C is equals to 20 over 9. That is, multiply 20 by 1, you get 20. C times 9, you get 9, and you divide this side by 9, which will give you 2.22 microfarads, and this is to 2 decimal places. So that is how you answer that. So Roman number 2, we are required to find the total charge stored. So charge, which is normally represented by Q, is equals to capacitance multiplied by voltage. So this is equals to, we have found in part 1, capacitance is 2.2. So because they were microfarads, we convert them to farads, so that by dividing by 1,000,000, that is 2 power 6, and you multiply by the voltage, which is 6 volt. So this will be able, if you can use your calculator, so you get it is 1.332. You multiply by 10 to power minus 5, and these are coulombs. The SI unit for charge is coulombs. So that's how you work out that. Roman number 3, we are supposed to get the potential difference across the 4 microfarad capacitor, and we say this V, that is the potential difference, is the charge divided by the capacitance. This is equals to, we have found in the previous part, number 2, it's 1.332. You multiply by 10 to power minus 5, that is the charge. You divide by the capacitance, which is 4, and you multiply by 10 to power minus 6. That is to convert these 4 microfarads to farads, so that we can be able to work with the coulombs, and this will give you 3.33. This is volts. So that is the potential difference, and we are using the total capacitance, which is the total charge, which we have calculated in the previous part. That is Roman number 2. So that is how you get that.